Our first lesson for chapter 11 is talking about permutation combinations and just different how we find totals. Make sure to write this down. Write all of this down. I will be looking for this on your notes. Counting principle is when you have multiple options. So the example here would be how many outfits can you make with 5 shirts, 3 pants, and 2 pairs of shoes. And once you write this down, make sure to leave a little space because as we go through these problems, we will be solving them. Permutation is one option and order matters. So this is how many ways can 5 students be chosen for president, vice president, and secretary. And the last one would be combination. One option and order does not matter. So how many ways can 2 students be picked to go to the bathroom out of 10? First one, we have a counting principle. A counting principle is just saying for the first shirts we have 5 different options. And for all of these when we're finding the total, we're multiplying. Because that could give me different options here. So we have 5 shirts, we have 3 types of pants, and we have 2 pairs of shoes. So this is going to give us our total of options of outfits. So if I multiply those all together, I would get 60 different types of outfits. So make sure you wrote the answer down right under the problem in your notes. Permutation. Permutation has one option. So the options here are we're looking for people to be in office. So that's my options. And order matters because if you're chosen for president, it's a lot different than if you're chosen for secretary. So when we're doing permutation, again, order matters. You want to start with the first option. So when I pick my president, I have 5 different options for that first one. Now when I pick my vice president, I already have my president, so I only have 4 options for my second person. And for my third person, I have 3 different options because I already picked 2. And then I multiply those together. I'm going to get 60 different options. I could rearrange 5 students as president, vice president, and secretary. So this first one is going to be permutation because order matters here, depending on what's in the folder. So you could write it out the long way. I have 12 options for the first folder. Then it's going to go down, and I'm putting all of the folders in my filing cabinet. So if I were to write them all down, it would look like this. However, there's a little shortcut how we could write this out. It's called a factorial. So I could write out 12 factorial, and it's just representing the same thing as above. So instead of writing out 12 all the way to 1, 12 and then an exclamation point, factorial is representing the same thing. So if I were to multiply all those numbers together, or use your calculator if you have a graphing calculator, you would end up with a very large number because since order matters here and there's so many different folders, there are a lot of different options that we could have for the order of the folders. So for the last one, I want you to attempt by yourself. So you should have got 40,320. Again, when I'm doing permutation, it's going to be at large numbers. The larger my total options are. We have a shortcut if you wish to do this when we're dealing with factorial, so you can do it on your calculator. Again, order matters here because we have first, second, and third place, and we have a total of 10 people. So you could do 10 times 9 times 8. However, sometimes that's going to be maybe a larger number, and it's harder to figure out. So how we represent this is a big P, because it's permutation because order matters. The number first is the total number of options we have. So we have 10 runners, so that's how many options we have to pick. And the order second is how many places are you actually picking. So I have first, second, and third. And there are no ties. So I have 10, choose 3. So using this formula right here, the first value is n. So my n here is going to make 10 because that's my total. So I could have 10 factorial over, and then in parentheses, I want to take my total minus how many I am picking or choosing from. So in this case, it would be 10 factorial over 7 factorial. And you're still going to get the same answer as if you did 10 times 9 times 8. So for this problem, we have 720 different ways that we could pick a first, a second, and third place runner. And our last one is combination. And our shortcut for combination is this formula right here, so you should write that down. And the reason why we have a little added step from permutation, because let's say if I wrote the word cat, in permutation there's only one correct way to do that. However, in combination, I could write out cat, I could write out CTA, I could write out TAC or ATC. So I have a lot of different options here, and I could keep on going. So when I'm figuring this out, I always have to have, this is how many my total I'm choosing, so it's going to have 13 factorial on top. So I'm going from this equation. And then I have my R, how many am I actually choosing? In this case, I'm choosing 4. So I'm going to have 4 factorial. And just like permutation, I have my how many total, so 13 minus how many I'm choosing factorial. So if you look at this simplified version, this would be the same thing as permutation right here. The reason why we have to divide by 4 factorial again is because we have to get rid of all of those options that were repeated with permutation, because we don't want to count an option like, let's say, this more than once. So when I figure this out, this is where I would use my graphing calculator. And I would have 715 different ways that I could have a group of 13 and choose 4 people from it. So right now I want you to test to make sure you can plug it into the formula for these next 3 problems and check your work with mine. Your 3 answers should have been 56, 36, and 3003. First problem, a chemistry teacher divides his class into 8 groups. Each group submits 1 drawing, and he has to select 4 drawings for display. So I'm just asking how many ways can he select the drawings. So the first part of this problem talks about groups. I don't have to care about that. I do have a total of 8 groups, so I know that that's my total. Now I have to think, is it permutation or combination? So does order matter here? When the teacher picks the 4 things, does it matter if group 1 was first or group 2 was first? No, because there's no evidence here that you get something for being first or fourth. So it's going to be combination. And so I have my total 8, and it's going to be combination, and I'm choosing 4. So now I want you to pause the video and come up with your answer. There's 70 ways that he could choose the drawings for display. Same thing, I want you to decide, is it permutation or combination? You will be drawing winners for a total of 25 tickets in a raffle. First person gets 100, second person gets 50, third person gets 10. How many ways can you draw the tickets? Well, the total number of tickets that I have is 25, so I'm going to write that down. And I have to decide, is it permutation or combination? So does order matter? Yes, it does, because it's going to make a difference if you get $100 compared to getting $10. And there's 3 different choices that we have here, so it would be 25, choose 3. So again, I want you to pause the video and come up with your answer. How many ways can you choose the winners? There would be 13,800 different ways you can choose the winner. Make sure that you have the beginning slide written down and the formulas for permutation and combination. And have a wonderful day.